Greetings, this is LameGuy64 of Tech Productions, and I'll be going through the process on how to install and set up the DTL-H2000 development boards onto a PC like this one in a step-by-step process while I'm reformatting my system since the Windows 98 installation of it was getting a bit flaky, and I wanted to have dual operating systems on it, Windows 98 and Windows 2000. I thought it would be a good idea to make a video supplementary to the DTL-H2000 installation guide in the PSXDEV forums to help individuals who have DTL-H2000s and would like to get them working again. And I'll be covering all the necessary details on how to set up the DTL-H2000 and setting up the SDK and then getting the debugger to work. So without further ado, let's get to it, shall we? In this case of this video, the computer that I'll be using to install the DTL-H2000 boards to will be a Dell Optiplex GX110 computer. Any computer should be compatible with the DTL-H2000 boards as long as it has at least 2 ISA slots, and the BIOS has options for reserving interrupts for legacy ISA devices. I'm not sure if, I think you could still get away with installing the DTL-H2000 boards on a motherboard BIOS that doesn't have an option to reserve interrupts for legacy ISA, but it'll make things a lot easier if you have those options available. So let's open up my rig, and as you can see, I've placed a padlock on mine just in case a lunatic collector might break into my house and steal my boards, which is highly doubtful because such collectors are non-existent in the Philippines that I'm aware of. Now, let's open her up. And there are my DTL-H2000 boards on the computer's card cage. I'm also going to be changing some cards here, removing some cards I don't need anymore and adding in ones that I need. Like a USB 2.0 card, which I had to remove one time because a driver screw up occurred, which caused the USB 2.0 card to prevent the system from booting properly. So there's the card cage with my development boards on there. So I'll just put this aside here and let's take a closer look on it. So here's a closer look of the card cage in a vertical orientation so you could see the peripherals better. And down here is obviously the DTL-H2000 boards. What I have installed at the moment in my Dell is a AverMedia M160 capture card, which I'll be removing because I no longer need it, and I'll be replacing it with a USB 2.0 card. Before I had the USB 2.0 card installed, but I had to remove it one time when a driver screw up happened, which prevented my system from starting up correctly with the USB 2.0 card, so I had to remove it. And down here is a Sound Blaster Odyssey sound card, which is not the best sound card for a Windows 98, Windows 2000 era system, but it's miles better than the SoundMax sound chipset included with the Dell. And down here is an S3 Savage 4 32MB PCI graphics card, which is a billion times better than the built-in Intel 810 graphics. And down here is the DTL-H2000 boards itself. The DTL-H2000 is more or less a PS1 in the form of 2 ISA cards with debugging capabilities. It's composed of 2 boards, CPU board on the top and the PIO board on the bottom, as the second card I meant. The CPU board, as the name suggests, contains all the processors that make up the PlayStation as well as the memory to run it. The DTL-H2000 has 8 megabytes of system RAM as opposed to the PlayStation, which only has 1 megabyte. The idea being that as a developer you have 8 megabytes to play around with which should hopefully make it easier for you to port your PC game projects to the PS1 without having where you just basically try to port your code first, as long as it fits within the memory constraints, and then once you get it up and running, you'll start optimizing your game to fit within the 2 megabytes of a retail system. That practice is actually very common. The Xbox also had double the memory. The development unit has double the memory than the retail, and same with the PS2 and GameCube. They have more memory in the development units for developers to use when porting projects to the console. So that's the CPU board, and down here is the PIO board, which is responsible for I/O stuff such as the controllers, I/O for the CD-ROM, whether it be a DTL-H2010 or 2510 CD-ROM drive, or the CD-ROM emulator card, which uses a SCSI hard disk as the image to store your ISO on, and then and also where you connect your DTL-H2700 performance analyzer board. So the most important thing the things to consider when you're getting into installing your DTL-H2000 is that you must have both boards. You cannot use the system with just one of either boards installed. You cannot use it with just a CPU board, and you cannot use it with a PIO board either. And you also need this ribbon cable to connect both boards together. I think it's a Yamaichi connector. I don't know. I haven't identified what connector it is, but looking through the their connector database should do the trick. I'm gonna be taking these boards out of the cage so I can show you the jumper settings which you must set before you install the boards into your system. Apparently the connector for the ribbon cable to connect the DTL-H2000 boards together is a Yamaichi NFS 100A. So if you have a pair of DTL-H2000s but don't have the ribbon cable, you can just try to source these connectors and crimp your own cable if you can. So here are my DTL-H2000 boards removed from the card cage. And before you install your DTL-H2000, you must make sure that the jumper settings are set correctly. The only jumper on the CPU board is the video standard jumper, which specifies to output video in NTSC or PAL standard. So make sure you have that set to the correct standard or standard that you want to use or work with. And the PIO board has a trickier set of jumpers which specify the interrupt I/O address and DMA channel for the boards. The switches here control the I/O address of the board. Right now it's set to the default address 1340, which I recommend sticking with. Because the logic to determine the correct jumper settings for a particular memory I/O address is very tricky. If you want more info on that, check out the guide in the PSXDEV forums. So yeah, I recommend sticking to 1340. Besides, I don't know of any peripherals that use that memory address, so it should be no problem in most cases. This jumper here specifies which interrupt to use. Right now it's set to interrupt 10, which is also the default, or you could set no interrupts by putting it on this pins here. But I don't recommend running the DTL-H2000 without a interrupt, because I think some features would not work correctly or not work at all, or lead to instability. And down here, these sets of pins designates which DMA channel to use. Mine is set to none. I think I think the DMA channel is only needed if you're using a 486, but I'm using a Pentium 3 system, so it works fine without DMA, so just set it to none as a default. And then one more thing to consider before you install is you must have a terminator connector or jumper on the connector where you would connect the CD-ROM module to, either a DTL-H2010 or DTL-H2510. In the case of the DTL-H2010, you would have a cable that you have to run through this hole here, and then you'd connect it there. But if you don't have either CD-ROM modules, you would need to have a terminator connector installed, which is just a Yamaichi NFS 40A connector, which would go here, and then we'll have a piece of wire that connects two pins together as the termination. Or you could just solder a little jumper like this one to replicate the terminator connector's functionality. It seems pretty easy to do. So the reason why you need to do this is that if you don't put a terminator on the CD-ROM drive connector, then if you try to use the SPU, your programs will lock up, or I think it will even lock up without even using the SPU. So I recommend having a jumper set there. A terminator set there, I mean. And then this connector here is where you'd connect your DTL-H2700 performance analyzer, and this connector here would connect to the I forget the DTL-H peripheral code, but it's basically a CD-ROM emulator board, which would connect to another ISA slot, and it will have a ribbon cable that would connect here. And then there's the massive boot ROM. In fact, the common thing about the DTL-H2000 is that it has a BIOS ROM that predates the retail BIOS, but there's nothing special in here. There's no startup animation according to the reverse engineer folk. And speaking of them, they mentioned that it had real-time clock functionality, which was dropped in the retail version. Kind of interesting, nonetheless. CPLDs, I imagine this is most of these are for interfacing with the performance analyzer. And also there are two versions of the CPU board. The earliest one has a ceramic heatsink on the CPU, which resembles the very early Japanese launch units, which had a ceramic, which also had a ceramic heatsink on the CPU. The difference with that, as opposed to this one, this revision of the DTL-H2000, is that the one with the ceramic heatsink has a bug where around 10 minutes of operation, there will be a I/O error. Memory writes in the scratch pad, I think, will not work. Would stop working properly in one processor cycle or something. Basically, the scratch pad I/O access is a bit screwy in the ones with the ceramic heatsink on them. But fortunately, this one is the newer DTL-H2000, which doesn't have that bug. And also, this I think most of these, or pretty much all the DTL-H2000s have the earlier version 1 GPU, which has a uglier looking textured polygon dithering, which I'll show you an image that I composited, which I've actually captured from this the early GPU screen cap came from this one, because this is the only PlayStation console I have that has the old GPU, and then the new GPU is captured on my regular stock consoles. So there's a bit of info to consider just in case. So yeah, once you have those things set up, you should be set for installing the boards to your system. You don't see that in most devices nowadays. Also, when choosing a computer to install your DTL-H2000 boards to, you may want to get one with a case that has these brackets for securing, not brackets, I think holders, to basically secure the full-length cards from wobbling around, which you don't want to happen with your DTL-H2000s. And let's install the cards. You also need to adjust this plate here so it'll fit with your slots. Also, I forgot to mention that the DTL-H2000 with the new CPU without the ceramic heatsink is known as the CPU2 board. The original one had the ceramic heatsink, so keep that in mind when you're trying to hunt down a DTL-H2000. I'll put the CPU board there. PIO incoming. Oh. I have a feeling these boards are actually a bit longer than even the longest high-end graphics processor out in the market. For highest end graphics card, ones with like 3 fans. I think these are longer. That's why you need the supports. Just screw them nice and tightly. Now you can order the boards any way you want. You can make the PIO board here and then CPU board and vice versa. The ribbon cable is a straight pair anyway, so it doesn't really matter. So let's connect the ribbon cable that connects both boards together. And there, ready to go. Now once that's done, you can now turn on the computer and see if the board works, but you need to first connect a TV to the DTL-H2000s. Abrupt cut because my camera ran out of memory. So before you turn on your DTL-H2000 equipped PC, you must first make some adapter cables so you could hook up a monitor and controllers to it. Because as you can see, the DTL-H2000 doesn't use the proprietary ports that were present on the retail PlayStation units. But fortunately, it uses just standard DB connectors, which would be a piece of cake to find. So this port here is your multi-AV out. This is not. It may be using a DB15 connector, the same as a VGA, but this is not VGA. I don't recommend plugging in a VGA monitor here, otherwise you might screw up the development boards, or you would screw up your monitor. So, and this one is the serial port, which runs at 3.3 volt TTL logic, same kind of logic used in the Raspberry Pi. And these two ports are your controller ports. I think this one is controller 1 or this one, I'm not sure. I think I gotta label them at some point. And I highly recommend putting a label here where this connector is not a VGA connector, just in case the unit that has these boards installed in would fall into someone's hands who doesn't know about these boards. So yeah, make sure that they plug it on the proper connector. Also, I moved my graphics card from here to here to see if disabling a jumper setting here would get it to work properly on the other PCIe slots and improve stability. So the recommended way to make a video cable for the DTL-H2000 is to, where is that adapter? Here it is. Where you basically take another female DB15 or DB15 connector, and then their focus, yeah. And then you just take a VGA cable with all the pins available. You want all the pins so that you can get to the video pins of the DTL-H2000. So you just connect this small adapter dongle onto this VGA cable, and then plug that to your, oh, that was a bit rough. Plug that to your DTL-H2000. Well, that's the recommended method on how to get a TV plugged to your DTL-H2000. As for controllers, the pinouts, I forgot to mention, you can find the pinouts of the multi-AV port of the DTL-H2000 in the PSXDEV guide on how to install the DTL-H2000. As for controller, you have to I recommend making your own out of parts out of the controller connector of a dead PS1, like this one, and then you just back out a bit, and then there, as you can see, I'm using UTP-8 wires to connect ports to the DB9 connectors on the other end. Basically, you just take the controller ports of a dead PS1 FAT, and then you cut this bit here to isolate both ports from each other, which is recommended. Otherwise, memory cards will not work, according to my friend Matt. And then at the end of the cable is the DB9 male connectors, which would go in here, for example. So yeah, you can find pinouts on this in the PSXDEV guide as well. So yeah, before you turn on your DTL-H2000 equipped system, the first thing you must make is just the AV cable, because you want to see a picture on the screen when you turn the boards on to verify that they're working fine. After a bit of fumbling to get this computer up and running again, once your DTL-H2000 equipped system is up and running, the easiest way at this step to know if your DTL-H2000s are functioning correctly is to look at the TV output of the H2000, and you should see a color pattern like this one. If you're seeing that, it's a good sign that the boards are functioning correctly. Now, once that's confirmed, you go, in the case of a Dell BIOS, you go to IRQ reservations and make sure interrupt 10 is set to reserve. In an award or AMI BIOS system, you just go to the PCI PNP configuration and then set resource control or IRQ assignment to manual, and then set interrupt 10 to legacy ISA or an equivalent term. Once that's set, you go to PCI IRQ assignment and make sure that none of the peripherals use interrupt 10. And in the case of award or AMI BIOS systems, you simply set reset configuration data to yes, save settings, and then that will get the motherboard to reassign IRQs for the PCI devices. So once that's set, you should be good to go to install Windows 98 or set up the development kits. I forget to mention that in the installation guide in the PSXDEV forums, it mentions that when setting up Windows 98 on a DTL-H2000 equipped system, that it is recommended to have all your expansion cards except the video card if it doesn't have on board, or if you're planning to use a discrete card. Is recommended. Actually, that's not really necessary, but in certain situations where you're having trouble with hardware conflicts, maybe doing that procedure will do. But in my case, I never had any issues in setting up the DTL-H2000 while after doing a fresh install of Windows 98 with a bunch of expansion cards already installed. I also need to mention that the video output quality will vary on the DTL-H2000 depending on the quality of your computer's power supply. If it's very cheap crap power supply, then expect to see fuzzy noise that scrolls up to the up the screen and then it loops back. But if you have a relatively high quality power supply, like in this Dell, it should be mostly noise free. Oh, and also the reason why you might have noticed that I'm not using my IBM keyboard, and that's because the keyboard unfortunately broke down while I was using it normally. The space bar stopped working and the down arrow key stopped working. Numpad 0 and numpad period also stopped working. I tried to fix it, but I was able to get numpad 0 and keypad period to work, but the space bar and down arrow key still didn't work. Quite unfortunate. But hopefully there's a store, a local store that sells a bunch of those for pretty cheap, so it's not much of a loss. Okay, so I finished setting up a fresh installation of Windows 98, as well as installed all the necessary drivers except the DTL-H2000. Actually doing a fresh installation of Windows 98 to get the DTL-H2000 boards to work isn't really necessary, but it may be easier since you don't have to deal with the plug-and-play stuff. But it's still possible. Just make sure that you have the resources pre-allocated before you install the boards. So anyway, the next step is to make sure that there are no devices that are conflicting with the development boards. So to do that, we have to go to System Properties, go to Device Manager, right click on the computer item, click Properties, and in the interrupt request list, make sure that there's no device using interrupt 10. In this case, there's no device using interrupt 10, so that's good. And in the input-output list, make sure that there's no device using address 1340. And in this case, there's no device using those addresses, so that's also good. Also, don't be alarmed if your development boards don't show up in the device manager. That's normal because the development boards are non-plug-and-play peripherals, and they behave like old-fashioned ISA cards. Especially with the old-fashioned jumper settings that you have to set to the correct configuration to make it work on your system. So once that's complete, the next step is to install the SDK to be able to develop PlayStation software and then run them on the DTL-H2000 dev boards. So there are two versions of the SDK that you can find floating around on the internet. The easiest place to find them is in the PSXDEV website. The first one, and is also the most popular, is the PsyQ SDK, which is an old leak of the SDK that was pulled from a development computer. Being that it was pulled from a development computer, it is very messy and also cluttered. So I don't really advise using that very much, especially when it will give you a bit of a headache when you use that kit to get the development boards to work. I recommend using the other one instead, which is the Programmer's Tool SDK. You can get it's available in the DTL-H2002 Programmer's Tool CD, which you can also download in the PSXDEV website. I recommend that, but it comes with library 4.3, but you can easily update it to library 4.7. So in this case of this video, I'm gonna be setting up my SDK installation of the Programmer's Tool SDK, simply because it's cleaner and easier to work with. Even though I recommend using the Programmer's Tool SDK, You may also want to get the Psycho SDK because there's some stuff there that's not available on the Programmer's Tool SDK. That is also pretty useful, and also such as some documentation that's not available in the Programmer's Tool CD. And also there are some programs, most notably the compiler, that are newer than the one provided in the Programmer's Tool CD. So basically you want to swap around the good stuff, bring the good stuff that you can find in the Psycho SDK and then bring that to your Programmer's Tool SDK installation. Actually, the Psycho SDK is that name was already made obsolete at some point during the PlayStation's lifespan, and was later renamed to PSSN instead. So now I'll be setting up my SDK from my file server. I'm gonna be pulling files from there. Public share, software, PlayStation Dev Kit, SDK CD. Well, these are the contents of the Programmer's Tool SDK. You got a setup program, but you don't really need this. Ooh, Programmer's Tool SCD, PlayStation Developer Software Resource. 1997. Well, the problem with this setup program is that it's a 16-bit application and therefore will not work in 64-bit versions of Windows, so that's pretty much useless. Even though you cannot get the setup program to work, you can still set up the SDK without using it anyway. You basically just need to copy the files. So the folders that you need to copy is cdgen if you plan to build ISO images on your development system using my MKPSX ISO program, or build CD. Then doc for some documentation. GNU, which contains the compiler, or just not copy that. This is not really, you only need to copy a few files in here, and you put them on a particular folder. You don't need those are just some references. Performance analyzer, you don't need that. PDA demo, no, we're not making games for the Pocket Station. PSSN, that's the SN system stuff. PSX, this contains the libraries and as well as sample code. PSX Graph, it contains all the graphics tools such as TimTool. PSX Sound, which contains sound tools. And Xdata, which contains external data that's used by the sample program. So, or maybe you could not copy that, or just copy it anyway. So you just basically copy that to your C drive, but before that you make a folder and name it PS, because PlayStation, and then you copy the files to that folder. So while that's being copied off my file server, one thing that that the installation guide in the PSXDEV forums got wrong was that the guide tells you that you need to install the DESI drivers located here, which contains the drivers for both the H2000 and 2500 boards for both Windows 95X, 95, 98, or NT. Actually, you don't install this driver if you're planning to use the SN Systems debugger, because this driver only works with Code Warrior, and therefore is useless if you're using the SN Systems debugger. It's even stated in a README file inside here that you should not install these drivers if you are using the SN Systems debugger. You could install it, but it will lead to some problems, especially weird ones. So, like for example, the file server would not work, and printed messages will not be received. So I advise not installing the DESI drivers if you're unless you're using Code Warrior. So yeah, but because the SN Systems debuggers, both the DOS and Windows versions, how they interface with the DTL-H2000 is that they will actually do direct I/O address to the boards, and it also explains why the SN Systems debuggers do not work under Windows NT based operating systems. However, you could get the 2500. It will actually, the Win32 debugger will work in Windows 2000, but because as it has a special driver that will allow it to be able to interface with the development board, but it only works on the DTL-H2000, unfortunately. Oh, forgot to copy the PSX icon. So once that's copied, the next step is to complete the PSSN compiler setup. So basically we go to the GNU folder, and then copy, or maybe we just copy the whole GNU folder. This folder is optional, but it contains some info that would be nice to keep locally, just the compiler documentation. So we basically need to copy these files to copy it and then place it in PSSN and bin and paste it there. Now once that's done, the next thing we need to do is to set up environment variables so we could start compiling in the command prompt using scimake for now. So to do that, we just simply go to our good old auto-execute.path and then write a line that basically appends to the path environment variable. So C, we want to be able to use the binaries in the PSSN folder and PSX folder. PSSN contains the SN Systems tools for developing with the DTL-H2000 and 2500. Cold Warrior uses a different development suite. So yeah, so C, PSSN, and then bin. Next, then C, PSX bin. We also want to be able to access the PSX graph tools. So no, I forgot I forgot the PS name. Folder. I forgot that folder. So PSX bin, C, PSX graph bin, and C, PS. I want to be able to use the sound tools. Yeah, I don't think we need the sound tools for now. So basically these are the most important paths to include. You would want to have CPS PSSN bin, CPS PSX bin, CPS PSX graph bin. That way you'll be able to use the programs in these four directories. So you just save that, and to apply it, we simply reboot the computer. Okay, we have now rebooted the computer. Now, next step is to make sure that we got the environment variable set correctly. So we bring up the command prompt. And I think I'll just go full screen so you can see better. And mode 80/25. There we go. Then we make sure that the path environment variable paths are set correctly. So we got path C Windows. There's our paths: C PS PSSN bin, PSX bin, PSX graph bin, and then to confirm that the paths are set correctly, we type scimake to test the make program. This make program is a DOS program, so it of course doesn't work with 64-bit versions of Windows, and is also very limited. I recommend just using the make program that came with the TDM GCC compiler and then MSys as well. But don't use the make program from MSys because that one is buggy. It's bugged in Windows 98. So I recommend using the make program that came with the code blocks, MinGW compiler, GCC compiler, or the TDM GCC compiler. And then we type in, to test the compiler, we type CCPSX, so it works. Now let's try compiling some example programs. So CPS, PSXX, then we go to sample PSX graph. No, not PSX graph, it's graphics. And we're gonna try DMPSX, and then we first I want to make sure what the make file does. So we type scimake here. Oops. Looks like we have a bit of an issue with the sn.ini or psycho.ini file. Hopefully that's very easy to fix. So seems to be nothing wrong. Strange. I forgot another environment variable. So looks like you need to specify sn path. So you get set sn path c ps pssn bin. I forgot about that. So you gotta make sure that you got your sn path set. Now you have to reboot. Of course, good old Windows 98. Okay, we have now rebooted the second time. Hopefully the CCPSX the compiler should work fine now. So we will bring up the command prompt. And let's try compiling the sample programs, one of the sample programs again. And graphics, DMPSX, then type scimake. There we go. Compiler is working now. Now you're ready to do some PlayStation development. So I think, yeah, to test if the debug, now we would like to run the program on the DTL-H2000. So to do that, first we need to make a little batch file, or modify a little batch file to make debugging a bit easy. Working with the development board's a little easier. So it's in PSSN bin RP, not role. It doesn't mean role play. You need to change this to sn path. This is then we put at echo off, reset ps, put a 1 there, put w5. The reason why we need to modify this batch program is so it'll be easier to deal with, and this little batch program will make it easier to reset your development boards under a DOS prompt. So once we have that fixed, the next thing we need to do is to set up the DexBIOS driver, TSR. You can use the DTL-H2000's boards, or even the 2500 under MS-DOS. So you can either use both the MS-DOS debugger or the Windows-based debugger. I recommend going with the Windows-based debugger simply because you can take advantage of the high-resolution desktop if you have such a configuration that can handle that, and be able to view a lot of things at once. And also the DOS debugger is a bit clunky to work with. So to run a program on the DTL-H2000, we need to first set up DexBIOS. We simply type DexBIOS A /A1340, that's our IO address, I interrupt 10, and then we enter. Installed OK, card address 1340, interrupt 10. So it's working now. And then every time you do a reset on the DTL-H2000, the screen would flicker. So to reset, we would just type RP. This is why we need to modify the batch program. I'm going to show you to do a little fix. I'm going to show you that the screen will indeed flicker if you restart the boards, which I'm going to show here. So I'm going to RP again. So there, screen flickered. That's fun. That's a good sign that there's some interfacing going on. So now is to run a program on the H2000. You type run W5 and then your program name. I forget the name. So there, run W5 to 0 CP, and there we go, it's running. I didn't have my controller adapter attached yet, since we don't really, but we have a running program now, so it's a good sign that the H2000 will work. Its execution is working fine. Now is to test the message system. Also, I think I forgot to mention this in an earlier cut, but the biggest problem with the PSXDEV is that there's a mismatch between DMPSX and the tools for some of the tools that control the development board, such as TestMess and Debug PSX, are mismatched versions, which means that things like printf messages will not work because of the version mismatch of the program. So that's another reason why I recommend using the Programmer's Tool SDK, simply because all the files are pretty much compatible. So now the next step is to type testmess. Oh wait, I think you need to install a TSR first. So mess1. After you install DexBios, you also need to install mess1, which sets up a message server TSR. What's a message server is the one that receives printf messages that have been output by your program, and you can print them out using testmess. But right now we don't have anything in the buffer, anything in the message buffer, so it's blank. So what we're gonna do is to restart the program, and then I actually recommend you to also get DOS key and then have it load every time Windows 98 starts, to make the command prompt easier to work with, MS-DOS prompt easier to work with, because there's no previous line thing. So if you run the program, we got it running now. Now we type testmess, and we have now messages. These printf messages came from the console libraries. This one is from the controller basic controller library, which is used for debugging since it does not support the analog controllers. This one is from the graphics library, reset graphics command function, I mean. So we get our message window working fine. Now the next step is to test if the PC file system is working. What the PC file system is, it's only available to the SN Systems development tools. It basically allows you to access files from your hard disk, so you don't have to have a batch file that will load files to the development board's memory, which makes it more versatile and easier to work with. So to test that, we go to etc. Or is it? I think it's in SCEA. There it is, PCFS. it's already built. So RP, restart the boards. So you don't have to type in 2 commands every time you need to restart the boards. So that's why we need a patch file. So hello CPE. Then we type test mess, and those are the results from the test program. And it looks like our PC file system is working fine. So that's good. And then it outputs the results to this. The PC file system also allows you to write data to the computer's hard disk. Oops, forgot to type in edit. And this is what it had wrote. So yeah, having PCFS is essential. The Kitela and CatFlap also have a similar functionality, but it's only read only. Because if I try to write the program, the system just locks up. I imagine they didn't put the right routines. So basically use libsn functions to be able to interface to use PCFS. You could just use this example as a reference. So now we have a fully functional compiler, and we can run programs on the development boards. The next step is to test the debugger. And okay, turns out that you need to put some parameters to be able to get debugging working on the system, on your program. So we need to edit our Sonic program, edit, make file at Mac. This is mostly just an example. So to be able to make your program debuggable, I can't think of a better term. Make sure you don't have optimizations. Then you just specify G, then XM, then specify the same on this step here, G, XM. What this does is that it'll generate debug symbols, which is necessary to get the debugger to work. So save that, then we recompile. Once it's recompiled, you should be able to debug now. RP, then debug PSXDEV/E220. Okay, now it's loaded, and we have now source view. The advantage of a debugger is that you can really do some debugging, which is very handy when you're working on a program and you need to figure out why your program isn't working properly. So basically it allows you to step by step at line by line. So to step here, I think you press F7. Yep. Then F7. Okay, the screen went blank because we passed. The screen went blank because we went to reset graph, and it turned off the display output for temporarily. So set graph debug. It will be set to 0. Initialize geometry engine and some macros that. So yeah, basically it allows you to step by step, and if you press space, you can debug at raw assembly level. You can also debug assembler source as well. And so press F7. You're gonna intercept this mask, and then that's the code, IO stuff, by the looks of it. And okay, and we can even set breakpoints by right-clicking, and then you could also create new on the window up here. Displays your processor registers, and they update in real time. And you can like split your window, so you could change this into a if you're you can set its type to either be a memory view, like let's go to address 8001.00.00. and that's some bit of our executable loaded in RAM. You can view RAM using that, and then you could also have watches. You could insert one by pressing insert and typing in the name of the symbol or variable here, and then you could also change that to a message window, so you can see your printf messages here. Being that this is a DOS application, it's limited to either 80 by 25 or 80 by 50. You can also have local variables, and you can view their contents. Abrupt cut because my camera ran out of memory while I was recording. So basically, that's the DOS based SN Systems debuggers. I don't really recommend using it since unless you're stuck using MS-DOS, because the limited DOS text mode resolution can get a bit cramped when you use it more extensively. So I advise using the Windows based debugging tool, which fortunately is included with the Programmer's Tool CD. You just basically go to your SDK installation, go to PSSN, WinDebug, and then setup. You can actually install this in Windows 2000, but it'll extract a special driver for the DTL-H2000 only. So we got CPS, I'm going to set this to PSSN bin, GNUC compiler PSSN, and SN debugger, let's just name it SN debug. And then the hardware, you make sure that you set you use DTL-H2000 if you're using a DTL-H2000, 2500 or 2700. So I think you use this if you have a 2700 and 2000 paired together. So it's okay, and then okay that, and then here we set our DEX settings. Our DTL-H2000 is address 1340, interrupt is 10. So make sure you set those in the correct settings. So okay, address 1340, interrupt 10, so yes, and then add shortcuts to the Smart Start menu. Now it's installed, and then it'll load up a web page of the README page of the program. So let's just close that, and then to use the debugger, first you go to programs. Before you use it, you gotta check for system for errors. So click that, and then run diagnostic check. This will test everything on the from install plugins, Windows system, registry, target connection, and then it'll test system files. So we get a pass, and it's, oh, I thought my computer blue screen there. That was weird. So now that the SN debugger is working fine, before you run the debugger, you must run the SN file server first. The interesting thing about the SN debugger is that the older versions required a dongle, a parallel port dongle device, which the developers eventually found to be frustrating to work with, so they made a patch for that program. The version of the debugger that had that is the one available in the PSXDEV forums. But fortunately, the Programmer's Tool CD has a newer version of the program, which no longer requires the dongle anymore. So no need of patching. So once the file server is working, you can set the file serving directory, which will be the directory where your PC drive access will be located. So we're gonna run a program. So first we reboot target by selecting that option or Control X, and the screen flickers a bit. Now we click on Run CPE or Control R. Then we select our program. from the samples. Graphics, PSX, since we already have the debug symbols on it, and we already have the program running under using a Windows-based tool. Now, for the fun bit, we're gonna be using the debugger. So we're gonna restart the, reboot the file server. And then we're gonna load up the debugger. Now, to set up a program for debug on the so yeah, this is the advantage of the Windows-based debugger. It's an MDI application, so you can make good use of your video display setup if you have a high-res monitor. So to load the program, you gotta go to Project, like Files, add your CPE file here, PSX sample, and then graphics, PSX. So I could find it. There it is, silly me. So you can add the CP file, check that, and then don't check this if you want the program to stay halted once loaded, so you could do step by step early on. And then to add the symbols file, and then select its target there, then close it. Now to then you can save your project. We'll just save it as PSX. Then you reopen, and then you'll load your program to the development board, boards, and then you can now perform. I think you can also create. Let's create a window that will display the source code. So to do that, because this one is disassembly and memory only, it doesn't display source code. So to be able to display source code, you create a window, change its pane to source, and then you already got your file references here based on source code references here based on the symbol files. So why don't we put a breakpoint at right over here. So we put a breakpoint there by pressing F5 as a breakpoint. So once we run the program by pressing F9, I think if you can have more options here if you have a higher res monitor, like a toolbar. And you can show toolbar there. You can also do control here, but for the meantime I'm gonna use the keyboard since it's easier for me to do and I'm more familiar with it. So now to run the program we press F9 and it should break at our breakpoint. So run, and there, it broke there. Then we can do step by step by pressing F7. So yeah, that's the debugger, Windows-based debugger in action, and that's how to get it to work. Every time you need to reload, you just simply reload your reopen your project by pressing Ctrl R. So the setup is that you would have IDE running alongside the debugger. The IDE will be where you would do the coding, and then a command prompt to do the compiling, or the compiling will be done by the IDE. And then every time you recompile and then you need to execute, you reload your program, and then on occasion you need to reboot. I forgot to mention that when you're working with the SN debuggers, both the MS-DOS and Windows versions, that you must put a poll host function within your main program loops. Because you can find that function in libsn.h, and the reason why you want to call that function in your main loops, you don't need to call it in your small loops, just in the big main loop that runs indefinitely, is because if you don't execute poll host, as the case with this program, the program will run fine, but the debugger will lose connection. So you must call poll host in your main loops. Also, when you're working, when you're gonna run your program from your DTL-H2000 to a regular PlayStation, you must also remove poll host, because that will cause a break instruction exception with the CPU. Because that's what poll host does. It calls the break. It executes a break instruction with a special break code. And there you have it. That's how you install the DTL-H2000 development boards onto a computer like this one. I forgot to mention in an earlier part that your printed messages will appear in the SN file server program here. When you're running the SN debugger, make sure you have the file server running, otherwise the program will cause the computer to crash and blue screen. So I hope you found this video very helpful to those who own the DTL-H2000 and would like to get it working on a computer for showing off in most cases. And I hope you enjoyed it, and leave a like or comment if you want, and maybe share this video if you don't mind. And as always, thanks for watching. DMGuy64 is signing out, and have a good day.